Welcome, everybody, to the HAI Weekly Research Seminar. I'm Jan Spies. I'm an econometrician in the OIT group at Stanford GSB, and I'm very thrilled to introduce Sarah Bana today. Sarah is a postdoctoral fellow at Stanford's Digital Economy Lab, which is part of Stanford's Institute for Human-Centered Artificial Intelligence, or HAI. And her research uses online data to characterize technologies, tasks, and the interactions between them to answer fundamental questions about the evolution of work. So let me give you a brief overview over what to expect today. So in her talk today, Sarah will discuss her recent work applying natural language processing techniques to build a model that predicts salaries from job postings with impressive accuracy. This model serves as the basis for estimating the effect of salary premia for various characteristics, degrees, and certificates. So very much looking forward to your talk, Sarah. Before we begin, let me just give a few more details on logistics. So first of all, if you want to ask questions, then you can use the QR code that you see on the screen right now to find a link to Slido where you can post your questions. I will then be drawing from the questions from Slido when Sarah takes a break in her talk. And finally, we can also ask some more questions at the end of Sarah's talk. So Sarah, thanks again for joining us today. Please feel free to start sharing your screen. I'm looking forward to your talk.
Great, thank you so much. Great, can you see the slides okay? Perfect. So thanks so much, Jan, for the introduction, and hi for the opportunity to present. I'm really excited to be here to share this research in this venue in particular, because I believe it falls under the high focus area of augmenting human capabilities. And so you already got a summary of the talk, so I'll go ahead and start by motivating this work. There's really a massive amount of data that we create every single moment that we exist online. And one activity that more and more people have been doing online is searching for jobs. Firms post jobs and interact with candidates online, and workers look at and apply for jobs. And what this does is it provides a tremendous amount of information on jobs, on the order of 3 million postings a month. And with that many postings, it's really possible to look at differences by geography, by industry, by occupation, by firm, and by firm size. Differences that are potentially going to be obscured if we just ask a small sample of people. On top of that, these postings are really available for analysis in close to real time, which means there's potential to pick up changes very, very quickly. And so in this paper, I ask, does the text content of a job posting predict the salary offered? And if so, how do we measure in particular what text matters? Well, taking a step back, there's this growing evidence that the job tasks that workers perform and the skills that workers possess have predictive power for earnings. So just knowing someone's occupation, which is often all we know in the context of government data, isn't necessarily sufficient. Instead, if we can measure specific characteristics of people's work, then that's really important information for earnings. The real problem is that figuring out exactly what people do in their jobs is relatively costly through traditional survey-based methods. So if we wanted to capture some rare indicators like an economist using machine learning methods, we might need to survey a lot of people. If we wanted time series to look at, then we would measure this change at multiple points in time. And this time series element may be really critical if we know that technology change or globalization or policy or many other things are changing the composition of work. And so what online data does is it provides this tremendous opportunity to measure what matters. I'm certainly not the first person to come up with this insight. Marinescu and Wolthoff show that it's really important to take into account a worker's job title when measuring the relationship between wages and application behavior. David Deming and Lisa Kahn show that on average, within occupation, MSAs that require more skills also pay higher wages. And so I think these are really amazing studies. But what I'll show you in just a second is even if we look within MSA, within job title at workers in the same occupation, we might find variation that comes from job tasks that we might want to capture. And so I'm particularly interested in salary as an outcome, so I'll go ahead and focus on that. But there are clearly possibilities for job tasks to be related to mobility and other characteristics of work as well. So if you're on the job market like I am, you look at a lot of different job postings. Here's one at a sales associate at the Gap in Santa Clara, California. I've put on this left side the computer scraped version of the posting. And on the right side, what I'll do is I'll articulate sort of the human readable elements of it. And so what you can see is you're a sales associate at Gap in Santa Clara, California. You're responsible for engaging and connecting with our customers by providing excellent customer service, resulting in brand loyalty. And then it moves into the section called what do you do, which outlines the responsibilities of this worker: consistently treat all customers and employees with respect and contribute to a positive work environment, promote loyalty by educating customers about our loyalty programs, seek out and engage customers to drive sales and service using suggestive selling, be accountable to personal goals which contribute to overall store goals and results, and support sales floor, fitting room, cash wrap, back of the house as required. So I think this is a pretty standard job posting. And what I'm going to do now is I'm going to show you another one for comparison and then put them side by side. So let's look at the next one first. This one's a little bit longer. This one's at the Macy's in Santa Clara, California. And this one says, job overview. The seasonal jewelry sales associate is responsible for providing outstanding customer service in the jewelry and watch complex. This includes meeting hourly sales and star reward goals. So star rewards, for those of you who don't know, aren't Macy's customers, are the Macy's rewards program. On personal and departmental basis, demonstrating superior product knowledge to customers, building a clientele using the clientele system, offering the customer our extended plan, and creating a shopping experience that's going to make the customer feel welcome and comfortable. And then it says essential functions: be proficient in use of all POS, point of sales, and MPOS. I think that's mobile point of sale systems, including My Client and More and Macy's tablet app. And education and experience: high school diploma or equivalent preferred, previous selling experience required, preferably in fine jewelry. And so what I was hoping you all would do is tell me which one of these job postings do you think pays a higher salary? And so Casey is going to help us with a Zoom poll, and I figured you all would respond. So you're going to see a pop up and you can vote which posting pays more. We'll give you just a couple more seconds as the poll results come in. Great. So we've got a 25-75 split. 75% of the participants think that the one at Macy's pays more, and thinks that there are characteristics in the job posting that might contribute to that. Oh, so I'd love to hear what you think matters for this job posting. Why do you think the one at Macy's pays more? You can put your responses in the chat, and maybe Jan will get us started with some reasons why he thinks one of them might pay more.
So thanks. So rather than giving you my reasons, I'm simply going to give you some of the answers that are already coming in chat. So thanks everybody for being so engaged.
Perfect.
So 2 points that are made here is that Macy's in general would be associated with higher value items.
Okay.
And generally associated with higher price points. And a second one could be that you may need more technical proficiency or technical skills. So those are two of the points that are already coming through in chat right now.
Yeah, sounds great. So Macy's is a higher value place. The goods at Macy's might cost more, and therefore the worker at Macy's might be paid more. That's a great response. And then there are some technical skills that are being articulated. So in particular, I believe this bit about the apps are articulated in the Macy's posting, but not necessarily in the Gap posting. Anything else coming in that's interesting, Jan?
Yeah, so right now there's an additional consensus developing here in chat about more detail in the job description being also indicative of the difference in salary.
Yeah. So potentially more detail in the job description. It's true that the Macy's posting in this context is definitely a bit longer. Okay, so seems like we have a bit of a consensus that the Macy's posting pays a little bit more. or pays more. Now, the follow-up question, and Casey's going to put this one in the poll, is how different do you think that these salaries are? So we got amazing responses last time. Casey's going to put up the poll. How much more do you think that the Macy's posting pays? You can still guess that the Gap posting pays more, but alternatively, you can guess that the Macy's posting pays 0 to 5% more, 5 to 10% more, 10 to 20% more, or more than 20% more. So I'd love to hear folks' thoughts on this particular question. And while folks are answering, I just wanted to demonstrate that, or articulate that the purpose of the exercise is really to show you that there's a lot in the posting that matters, whether it's the firm name, just like we articulated, or the technical requirements articulated. There's a lot of characteristics that you all think might be worth measuring. This is really just an illustrative example, but it seems like a number of people have responded. Great. So we have a bit of a consensus that most people think that the Macy's posting pays 5 to 10% more, followed by 10 to 20% more. And so I'm going to just show you the results in this particular context. And so using some data that I'll use at a later point, the salary from, or I'll discuss more from at a later point, what we find is that the salary from the metadata of the Gap posting is around $32,000. And the prediction model that I'll talk more about throughout the course of this talk predicts around $33,000. So pretty good on this particular posting. Alternatively, the sales associate at Macy's, the salary from the metadata is around $41,500. And the salary from the prediction model is around also $41,000. And so really what I wanted to show you is that there are words in the job posting that are meaningful, and we can use those meanings to predict the salary associated with those postings. And so now I'll talk to you a little bit about how I do that. So there's a growing set of tools that are available to researchers. Job postings data is one tool. A lot of folks have been using this job postings data that I showed you scraped from Burning Glass Technologies. I'm going to add a few additional tools to this to the researcher's toolkit. The first one is a new data set source from a firm called Greenwich HR. What it does is it provides salaries that come from the metadata of job postings. What that means, and I'll talk to you more about this in a short while, is that oftentimes recruiters are asked to input salaries despite the fact that there was no salary in those particular postings. So Greenwich HR takes those recruiter inputted salaries or salary bands and produces metadata salaries for over 60% of job postings. And that value is increasing over time. And so with that salary data, then I'm able to do supervised learning, which I think is also a valuable tool in machine learning to answer this traditional economics question. The second tool is a natural language processing methods that allow us to distill the full text of the job posting. And so now I'm going to talk a little bit more about those natural language processing methods. What natural language processing methods do is turn words into context-dependent vectors. So modern NLP models like BERT, which I'm going to be using in this talk, help us turn words into context-dependent vectors. And so then the combination of these words as vectors and salaries turns this into what we might consider a classical supervised learning problem. So instead of us counting words that we think matter, for example, measuring the skill requirements or measuring the education and experience requirements, we can let the data decide and determine what, particularly in a posting, is associated with a higher or lower salary. And so these elements combined create a 21st century version of hedonic regression. And so those of you who are familiar with Rosen 1974 might be familiar with the concept of hedonic regression, where in this case, clearly both sides of the market are heterogeneous. We might look for different things in our jobs, and employers might look for different characteristics in us. And this produces equilibrium prices. These prices are going to shed light on the costs associated with these particular characteristics for firms. So what I can produce is a distribution of valuations for any job attribute, whether it's skills, amenities in a posting. And I think it's a really major complement to any labor force statistics that are currently being collected. Like any data set, there are a series of limitations, and I'm just going to be quite upfront about those. The first one is that I can't distinguish between signaling and human capital in the context of job postings. So for example, in the Macy's posting, we saw that previous retail experience was required. I don't know if previous retail experience in fine jewelry was necessary for the Macy's posting, or just potentially is a signaling device for the employer to find somebody who's had experience in that area. It's also prior to the negotiation process. So if you were really good at using point of sale systems and you went to Macy's and you said, hey, I'm really good at using point of sale systems, you should pay me more, that could be associated with a wage increase, but that's not something I'm going to necessarily measure in my data. And so just a paper in 2 slides, I use natural language processing models to predict the salary associated with a job posting. To the best of my knowledge, it's really the first paper to use the full text of the posting. The model is a supervised learning model, which is currently trained on over 800,000 postings. The key layer is going to be BERT embeddings, which are context-dependent dimensions for every single word in the posting. And so I can predict salaries from these job postings with an out-of-sample coefficient of variation, or R-squared, of 84%. What that means is that I can explain 84% of the salary from the text, which I think is a pretty remarkable amount. That's a 21% increase, or a 15 percentage point increase, over a model with occupation by MSA fixed effects, which is sort of the next best characteristic that we have a tendency to use in economics. And so really illustrating the power of words for a representative sample of postings. In the second part of the paper, what I do is I apply this model by creating a counterfactual posting by adding a marginal characteristic. So ultimately, we can take a posting and then we can say, well, if we added this particular characteristic to the posting, how much more is that going to affect their wage? And then I do that by predicting the salary of the counterfactual posting and then comparing the counterfactual posting's predicted salary to the original posting's predicted salary. That difference is going to be estimate of the wage premium associated with that characteristic for that job. And I apply it to online certifications or online learning and produce the first independent estimates of characteristics in the online certification space. This approach is really scalable to virtually any marginal job characteristic. So we can add any phrase to a job posting, and maybe you can make some suggestions for phrases you're interested in at the end, and I can add them to postings and see how those affect the postings. So that's sort of the summary. I'm going to go ahead and move on to that data, and love to take your questions after describing the 2 data sets. So I'm going to use 2 sources of job postings data in this paper. The first one is from a firm called Burning Glass Technologies. They collect job postings from over 40,000 online job boards and company websites. They have over 200 million postings in the past decade, and it's really been widely used by researchers for a variety of different applications. The key difference between what I do and what has been done in the past is using the full text of the posting. To the best of my knowledge, other researchers have only used keywords, and the keywords might be less informative than using the full text. The second data source is the new data source. It's from a firm called Greenwich HR. They too have job postings from millions of sources. Over the period April 2019 to September 2020, this amounts to around 62 million postings, and around 37 million of them, or around 60%, have salaries. These salaries come from the metadata of postings. Now, what does that particularly mean? Well, here I'm showing you some screenshots from some job board user interfaces on the employer side or the recruiter side. So you can see this particular screenshot from the website Indeed.com, where it asks the recruiter to input the pay associated with the job. The recruiter can put in the exact rate, hourly rate, or put in a range or starting at or up to. And it encourages the recruiter to put in this characteristic by telling them that if you tell them the pay, they'll receive up to 2 times more applications. Now, this in this particular context is not necessarily not necessarily a characteristic that recruiters need to fill out, but here's another example of this in the context of LinkedIn. So in LinkedIn, you can see, you can input the compensation associated with a job posting, the base salary and the additional compensation. And you can show the estimate from LinkedIn members for workers in the same role at the same firm in the same metropolitan statistical area. Now, this is just some screenshots, but I'll show you one more from careerbuilder.com. And this is on the job seeker side. So suppose I was looking for a data scientist job in Palo Alto, California. Well, I can actually filter my results based on what the recruiter has inputted. So the pay, limiting the pay to a job, say that was asking for at least $80,000 or offering at least $80,000. And so there's definitely some evidence of this data on the job seeker side. And so there's a really natural question of whether or not this particular data is representative. And so now I'm going to tackle that next. So you might ask, how selected are the posted salaries? Well, first, I wanted to articulate the fact that salaries that are collected from the metadata may differ in their selection from explicitly posted salaries. So we all might have seen job postings that articulate salaries in the text of the posting. These are not necessarily articulated in the text of the posting. And as you saw in both of these contexts, the salary wasn't in the posting, right? So how are salaries collected from the metadata selected? Well, I think the way I want to think about it, at least, is it's going to be partially a function of the posting website's listing protocols. And so if we at Stanford are being asked to put a certain job posting on inside higher education, that's one of our protocols, then what the inside higher education website does in terms of mandating or not mandating a recruiter inputted posting is a decision from their side. And so I think that this is more likely a decision at the firm level as opposed to the job level. And so I'm sure there are a number of questions on that dimension so far, Jan. Maybe I can stop here and then talk about a comparison to the CPS in a second.
Thank you so much. So first of all, I want to remind everybody that you can post your questions in Slido, and there you also have the opportunity to vote on those questions that are already there. There are already a few questions incoming here. One actually related to the representativeness is also one question here by Maria, whether the data you have here is representative of just basically specifically parts of the US market, or to which degree you think that the kind of data you have here would actually generalize beyond the US and beyond kind of Silicon Valley and tech.
Yeah. So first and foremost, the data is like pretty representative at the US level. And the salary is not really differentially posted across the US. So that's the first question. If we try to run a simple regression on whether or not you had the metadata salary on occupation by MSA fixed effects, for example, you'd only be able to explain 3% of the variation. And so what that means is that a lot of why a salary is posted isn't explained by the occupation or the location of the particular job. And then I think this leads me naturally to comparing this to the CPS. So the current population survey is sort of our best example of representative data in the US. The thing is that the CPS is measuring workers in jobs as opposed to job postings. So in particular, they're measuring usual weekly earnings before tax and including any overtime pay, commission, or tips usually received. And so what you can see from this figure is that GHR, the salary data, is better represented at the bottom of the distribution than it is at the top of the distribution. But that's not to say that I don't have any 300,000 plus job postings in the salary data. There are definitely a lot of variety of corporate jobs in the salary data. So it's kind of hard to make the comparison in terms of how representative it is in terms of the entire economy, because we don't really have a data source in the government to be able to that measures postings. To get at the question about representativeness around the world, I think that's a great one. In fact, most countries, for example, in the UK, it's more common to post a salary than it is in the US. And that's also true of a variety of other countries, especially if they're unionized. So when occupations are unionized, the salary or salary band is often dictated according to a schedule. And so in other countries, this process is potentially even easier.
Thanks a lot for responding to the question. I had one second related question coming in here from Max, asking about the impact of location companies on wage, which you already partly answered, but he also asked about seasonality. So whether you also have a possibility of estimating the effect of seasonality and how you estimate the negotiation bandwidth for the job offer. So rather than just a fixed salary, like how do you think of the negotiation bandwidth?
Yeah. So let me start with the first question about seasonality. So in this project, I'm only using currently April to December 2019 data. So that's all pre-COVID, partially because I don't necessarily want to get COVID involved. However, one of the values of this data is really the fact that there's a tremendous amount of data, and so we can run these models pretty much every month and see how the value of a certain characteristic is changing month to month. That's one of the promises of this type of project. In response to the second question, sorry, Jan, I think it slipped my mind. Do you mind articulating?
Sure. Sorry, I threw both of them at you at the same time.
Worries.
So this is also from the same question is
the band.
How you
right.
think of the bandwidth for the negotiation rather than just the basically point of one salary.
Yeah. So right now I'm only being given the point, the median of the salary band as opposed to the bottom and top. But I think that's a really great question, which is like, if you had the band, then what sorts of questions could you ask with the band? I think it's a great question. Right now, that's a data limitation, but hopefully one that'll be overcome in the future.
Okay, great. Thank you so much. There's some more questions coming in, but I think some of them will be a better fit for later parts of the talk. So why don't you continue now and we keep collecting questions. And as a reminder, please put your questions into Slido, and there you can also vote about questions that you would want to be asked, that you would want me to ask. Thank you.
Perfect. Thank you. So the next part of the talk is the model. And there are really two innovations in the model. The first one is supervised machine learning. And then the second one is natural language processing that turns words into vectors. And so let's talk about supervised learning first. Well, I always like to start from the place of simple regression. So let's suppose we were running a really simple linear regression on salary prediction, trying to predict salary. And so we might include important characteristics of jobs like education levels, experience levels. But why not just include interactions? Because we might think that a very high level position that required a lot of education, a lot of experience might be really different from a particular posting that just included a lower level of education, but a high level experience and vice versa. So we might want to include interactions, but even pairwise interactions are going to yield far too many covariates. And so we need a process to allow for interactions that have high weights in predicting salaries involved in our model. And so the solution is really supervised machine learning. Supervised learning, if you've attended some of these high talks in the past, excels at identifying patterns from data when both the inputs, in our case, the text, and the outputs, in our case, the salaries, are given. And so supervised learning models are going to minimize the same type of loss function as OLS, but with data-driven interactions, there's going to be this potential for overfitting. And so what I do to try and make sure that the model is learning true patterns is I'm going to split the sample into a training sample and a testing sample. And I'm just going to put that testing sample away. And then in this case, I should be able to evaluate the model on postings that the model has never seen before. And so that's going to demonstrate its accuracy on data that it's never seen. And so now that we have tools to characterize interactions, how do we have another problem, which is how do we turn words into something that's meaningful for salary prediction? Well, we can count the relevant words, or alternatively, we can count relevant phrases. But what's going to happen is there's going to be a lot of sparse matrices if we try and count relevant words or even relevant phrases, because the economy is just so diverse. There's so many different types of jobs that are being asked for. And so in a million different postings, there's just going to be a lot of sparse matrices. And we might have a situation in which the statement preferred, or the word preferred, or the word desire might imply the same concept. And we want to be able to characterize that as the same, at least in the context of job postings. And so the computer scientists, including the ones at Stanford, have a solution to this problem, which is word embeddings. Word embeddings are vectors for words such that words that are closer to one another are closer to one another in space, are also closer to one another in meaning. In this paper, I'm going to use pre-trained embeddings by Devlin et al. Called BERT. These are currently the basis for Google search. It's trained on English language Wikipedia, which is over millions and millions and millions of words, along with the book corpus, which is a series of novels, unpublished novels, which are additional words for the model. And it's trained using this task called mass language modeling. It's a self-supervised learning task. And so this approach facilitates turning a posting into a matrix where each token or word is represented by a vector. So the first step I'm going to take is tokenize a posting, or split it into words or subwords such that the model understands it. Then I'm going to allocate the posting to either the training or in-sample data set, or the testing or out-of-sample data set. I'm going to train the model on the outcome, in this case, log salary. We know that salary is not normally distributed, and so log salary is the outcome I'm going to use. And then I'm going to evaluate that on out-of-sample postings. I think this might be a good time to take some questions, Jan, if you have them.
Sure, absolutely. So one point by Ranger here is what the practical utility is actually of predicting posted salaries by posted job content, as opposed to trying to predict the actual salary that employees get based on what they see from the job posting. So just basically about the setup of your prediction problem here, and the fact that both the outcome is the posted salary and the right-hand side is the posted job content.
Yeah, so I think that in reality, we want large-scale data that has accessibility for the public and is really easy to capture. And so I think that the question that's being asked, it would be fascinating if it could be captured. In reality, we don't have workers' salaries, what they are actually making, and the characteristics of their job. And if we could, then I agree completely with the questioner that would be a more interesting question. Unfortunately, we don't have what people are actually doing at work, and so that's one of the reasons why online data provides this opportunity.
Thanks a lot. I'm going to give you a second question. Feel free to defer it if that's too early to ask now, which is Matthew Darling has a question whether there would be a way to nowcast changes to wages using your method. So could we basically get early estimates before seeing the CPS by using the setup in order to do nowcasting?
Yeah, absolutely. So I think so. And right now, like I said earlier, this is only using pre-COVID data from 2019. And so in that context, I'm not necessarily doing any nowcasting, but I think the objective would be to say, okay, well, now we have all the postings for the month. Can we try and identify how wages are going to change in a meaningful way, such that we can use that information to make major policy decisions? I think it's a great question and definitely something we want to do. I think that we have to recognize that at least in our current time, bargaining power between employers and workers is changing. And so that's not necessarily, if that can be captured accurately by postings and metadata salaries, then I think that would be valuable to nowcast. But I would be really interested in answering that question. Absolutely, Matt. Thank you for your question.
Great, thanks so much. So there are more questions coming in. Please keep posting them and voting on the questions. I'm going to ask you more when you take your next break. Thank you.
Perfect, thank you. And so now I'm going to show you a little bit about how the model does. So the first baseline that I'm going to use, and these are baselines that are compared to the natural language processing model that I use, that's on the right side. So I'm just going to build up this comparison. So the outcome in this context is out of sample coefficient of variation. So some of you all might know this as R squared. R squared really says how much of the variation can you explain by what you have in the data. And so I start with the burning glass 6-digit SOC standard occupation classification fixed effects. And so what you can see in the first column is that just including occupation fixed effects, you can explain 61% of the salaries. But in reality, burning glass isn't able to capture, let's say, 5% of occupations. It's not able to allocate those postings to a given occupation. And so when you add those 5% of postings that we have trouble characterizing, or they've had trouble characterizing, then you can see that the R squared drops a little bit, unsurprisingly, to around 59%. So you can think that the baseline of occupation fixed effects is around 59%. We can explain 59% of the variation in posted salaries using 6-digit occupation fixed effects. And so the next two columns are going to add metropolitan statistical area fixed effects. And so the first one is going to add them separately. So that explains 62% of the variation. And then when we add them together and we say, well, maybe a data scientist in Silicon Valley is potentially different from a data scientist in Atlanta, and adding those fixed effects in, then we get to just under 70% of the variation. And so once again, this is all on the out of sample postings. We use around 800,000 for the training sample, and then around 200,000 for this testing sample. And so by comparison, the natural language processing model does really well. I can explain 84% of the variation in salaries through the text of the job posting. So certainly there's information between these two baselines. And so I can run this or demonstrate the same phenomenon when I look at root mean squared error. What I just want you to see here is that the root mean squared error, which is a measure of prediction loss, is really weak or very similar across the first four columns, but the natural language processing model drops the root mean squared error down pretty substantially to around 0.2. And so that's the model. Maybe I'll take a couple questions before we get into the empirical approach. Yeah.
Sounds good. So first of all, I actually had one question here as you start getting into the model performance, which is when we think of the different predictors that we may have here, you already talked before about the fact that some of them may be related to specific skills, others may be related to ways that those skills are presented. I was curious to which degree this could also be about the style of the posting in ways that is not directly captured by describing a skill, but maybe just because there is a typo in the posting, and a firm that makes typos in their posting tends to be one with lower wages. Like, once we talk about language, like, do you have a sense of how these things decompose, and which of those would be relevant to your research question here?
Yeah. So I think you're absolutely right that using the full text of the data allows you to get at these nuances above and beyond things that that are substantial, right? Which are things like skills or education. Also things that are potentially less substantial and more stylistic. And I agree. I think that if you have a typo or the way that you write about a particular posting, it provides, or a particular job provides a lot of information. I currently don't necessarily have a good way of getting at that, but I certainly think that that's part of what's going on here.
Thanks a lot. We have a few more questions. Let me just check which one would be best to ask you at this point. So Jinso actually asked a question how you would answer the question whether there is valuable information here and not just noise. So how would you show that these job postings actually contain true information when the data itself is quite noisy and unclean? Could that be a mere association in this data? Like what's, like how would you answer to a question that says this is very noisy? How can we actually say that there is truly valuable information here? But I feel like you're almost on the slide to answer exactly that question.
Yeah. So I'll go back to this one, which is like if the posting didn't have information, and honestly, like I think that at least when I had conversations with this with others prior to starting this project, people thought that what was written in a posting wouldn't be meaningful. And in reality, what I found is that what's written in a posting is tremendously meaningful because it explains, in my opinion, so much more than I thought it would explain. There's so much information in the text of the data. And in reality, like that information explains 84% of the variation in salaries. And I think if you ask the random economist or information systems researcher on the street, they wouldn't think that that much information is being conveyed by the words. And so at least in the context of the Macy's and Gap postings that we saw earlier, you could tell that there were skills that were being asked for in one context that weren't necessarily being asked for in another. And so it's really exciting to think that the job posting data, which is once again accessible in a way that a lot of other things aren't, provides that kind of information.
Thanks a lot. Let me ask you one last question here,
Yeah,
actually related to the point I also asked. So Max wants to know a little bit more about how you extract information from job postings. He asked, do you average all the token word vectors? If not, how do you consider the weight of the tokens or words? And then finally, do you also extract the job skills out of the job posting? So I think that last point being related to also the question I asked, how much more do we know about the content that you extract here?
Yeah. So I'm going to treat this like a supervised learning problem, and I'm not going to characterize anything separately myself. And so what I'm going to do is I'm going to take this job posting and I'm going to run it through a BERT layer. So 512 tokens is going to be the limit in terms of the length. So let me just point out the fact that while some folks said, the Macy's posting was definitely longer than the Gap posting, the model can only take 512 tokens. And so I'm going to have to treat the length of the posting as similar across those, or only just take the first 512. And so I'm going to take that posting and I'm going to run it through a BERT layer. And then that BERT layer is going to spit out 768 dimensions for every single token in the posting based on the words around it. And so then I'm going to have a convolutional layer, a max pooling layer, and then a dense layer to be able to predict salary. And so this is going to be supervised learning. So I'm going to have a training set, and within that training set, I'm going to have a validation set. And so it's going to determine using that training set what weights are valuable after it looks at a number of postings, looks at the relationships between these dimensions, and then predicts the weights. And so there's no feature extraction that I'm going to manually do in this process. It's all automatically done.
Thank you so much. So in the interest of time, please continue now, and then I have some more questions for you in the end.
Perfect. Sounds good. So now I'm going to talk a little bit about the empirical approach to this, which comes from work with Eric Brynjolfsson, Daniel Rock, and Sebastian Steffen, what we call text injection experiments. And so we're going to construct, or with this project, I'm going to construct a set of counterfactual postings by adding a phrase to the end of the posting. And then I'm going to use the salary model to predict the salary of that counterfactual posting. And so I'm going to take the difference between that predicted salary of the counterfactual posting with the additional characteristic and the predicted salary of the original posting. And that's going to provide a premium associated with that characteristic. And so I'm going to apply this to the space of online education. Let me first tell you that this whole process is sort of agnostic about what makes a good and bad counterfactual. So before I do that, I'm going to construct a variety of counterfactuals. So you might think that many truck driver postings don't really ask for computer networking skills. So I'll limit the sample to occupations that have asked for that characteristic in a prior time period. And this approach is going to lend itself very naturally to heterogeneity. That is, we can add computer networking skills to a data engineer, or we can add computer networking skills to a software developer or a hardware developer and see how that affects the various different types of jobs. And so let me show you how I apply it. Well, as you might know, as of 2020, the number of online certifications or certificates and digital badges have exceeded the number of degrees or certificates from post-secondary institutions. You might be yourself involved in one of these professional certificates that are being advertised by websites like Coursera, so you can take this IBM data analyst program or the Salesforce sales development representative program. And I think that understanding this space is quite interesting because first and foremost, not just interesting, but valuable. First and foremost, because these programs are more accessible to larger swaths of the population. So unlike a lot of us who spent 6 years working in a PhD program to achieve a credential of a doctoral degree, a lot of people might not necessarily have time for these very intensive programs. So instead, they can take these shorter, more narrowly focused programs that are offered in a flexible time frame. So this type of micro-credentialing or small human capital investment may very well increase productivity, but in reality, there's no clear way to understand the potential earnings consequence. And I think that that's potentially unfortunate because these programs are growing at an unprecedented rate. And so we might want to understand the value of these programs for the workers that could be involved in this sort of human capital accumulation. And so I apply this to Indeed's 10 in-demand career certifications. This is going to be the first, these are going to be the first independent estimates of these. And I think that that's important because of the principal agent problems that are inherent with certification programs. So you can think about the fact that the same governing body that's granting the certification is oftentimes evaluating the certification. And so that causes a bit of a principal agent problem or a moral hazard problem in general. And so we might want to independently evaluate the value of these programs for workers. This measurement can also be shared in close to real time and with heterogeneity. So like Matt referenced, can we now cast some of these things? Putting these two concepts together, you might remember that they were looking for a lot of contact tracers at the beginning of COVID. Well, contact tracing wasn't necessarily a thing prior to COVID, at least in the US generally. And so contact tracing might be a certification that's value is changing in close to real time. And so these are the certification programs that I'm going to evaluate from this in-demand career certification list. There are here on the right, the reason why I think this is particularly valuable is because here on the right, these programs actually have a physical cost associated with obtaining these certifications above and beyond the opportunity cost. And so, for example, if you wanted to become a project management professional, you have to enroll in a testing regime that's going to cost somewhere between $405 and $555. And so there's a very natural way to evaluate the cost and benefits of these programs. And that's what I'm going to do next. So I'll just show you one quick example, which is the International Institute for Business Analysis, Agile Analysis certification. And so I can add that phrase to the end of a number of different job postings and see how it increases the salary associated with those job postings. This is a 0.06 log point increase, which amounts to around $3,000. But the IIBA-AAC may not be asked for in most postings, and you can see a lot of postings are sort of at the bottom end of the distribution that experience this wage increase. And so on the right side, I show you another figure where we've only added, or I've only added the characteristic to postings that are in occupations that have asked for this characteristic in the past. And so it's a smaller log point increase, but it's still pretty substantial. It's associated with around a $3,000 increase in the predicted salary associated with the job posting. And so here I've done this with the in-demand certification listed in that Indeed article. On the x-axis is the median cost of the certification. On the y-axis is the predicted change in annual salary. I haven't necessarily, I've been pretty agnostic as to how long these certifications are going to be valuable for workers. But you can see that there's a really large range of premia, while the certified associate in project management is associated with a pretty high change in annual salary. The certified supply chain professional is below the 45-degree line, implying that it might take more than 1 year to obtain the return associated with that particular certification. And so I will take questions here, or maybe let me conclude and then we can take questions. So the conclusion is really that the text of the posting matters, and we can use it. So here in this paper, I developed this supervised learning model using the metadata salaries and demonstrate that it explains significantly more variation than a model with occupation by location fixed effects. And this really provides us countless possibilities to evaluate the characteristics of jobs in close to real time, like Matt said, but also differences by place and by occupation. And we might think that those differences are very meaningful. So as both firms and workers make strategic decisions about their human capital, I think this kind of information is a really crucial input for those workers and firms trying to decide exactly how to invest and deploy their human capital. This is applicable to a wide variety of contexts. I focused on reskilling in this paper, but we can think about it in a variety of different contexts. In the reskilling domain, advice is quite broad, but we know that skills may be valued differently in different places. The marginal skill could be different in different roles. And we might imagine this type of advice should change over time based on the labor market conditions that it's being given under. And so I think it really relates to this potentially new paradigm underpinned by better labor market information that could improve our approach to workforce education and training. And here I've highlighted a book that's really inspired some of this work. So let me just say thank you and take the rest of the questions that folks have.
Thank you so much, Sarah. And thanks everybody for the questions. Please continue to ask your questions and vote on them. So there are a few that I think you already answered, including on a comparison to a company occupation location fixed effect model. So let me maybe right away go to one that I'm curious about that may not already be answered, which is whether the data includes any other features on demographics like race, ethnicity, and so on that could also influence the accuracy like MSA and occupation could. And if not, is that something that would be beneficial to add?
Yeah, so I think it's really, I mean, of course, demographic characteristics affect all sorts of things. In reality, this is posting data. So when you have a posting, it's not associated with a person until the person is hired. And so I do think that there are applications of this work for pay equity type of questions. So you can think about having postings that, trying to understand within a smaller firm, if you didn't have very many women, trying to understand whether or not somebody is overpaid or underpaid relative to the characteristics of the posting. But posting data itself isn't associated with any demographic characteristics.
Thanks so much. So I'm just going to throw a few more questions at you. So two people, Laila and Harsha, are both asking about the tokenization of the post. Yeah, so do you simply tokenize the whole job ad and then use the vectors of all the tokens as an input, or is there any other steps you go through?
Yeah, no, so that's it. So I'm just going to take the first 100 and 512. Well, first I'm going to tokenize the entire posting, and then I'm going to take the first 512 tokens. So there's no process, there's no additional pre-processing there. So for example, the line breaks and things are all preserved in the context of the posting.
That's great. And then I'll give you one more question from Caroline Williams, who asked whether there's any data regarding how many people who obtain these certifications are hired for positions using their new skills. So whether you can actually say anything about whether the skills in this job posting is in any way related to them being hired.
Yeah. So that's a great question. I think that a different sort of data source would be necessary for that particular question. So you'd need a job posting series of applicants for a posting that had skills and didn't have skills, or had certifications and didn't have certifications. That's not something I have in this context, but definitely a very interesting question to ask.
Okay, thank you. So Sebastian has an interesting question about potential implications for using this in practice. He writes, such a tool could be a great asset before entering salary negotiations, especially for underrepresented groups, as it tells people what their skills are really worth. Question he asked is whether you think that companies might start altering their job postings via adversarial methods so they can keep up the upper hand in tasks. So in other words, like, if somebody uses your research, what would actually be the implication of being sophisticated about that?
Yeah, I definitely think that if we had the power to change the general equilibrium, I would be pleasantly surprised. But I do think that right now there is interest in changing the articulation of postings. Let me take this from the perspective of not the firm being bad, but the firm being a positive actor. If we thought about the firm putting in a characteristic and saying, that's associated with a really high wage, and then realizing, we don't actually need that particular characteristic in this worker, that the worker can either learn that skill on the job, or this would change our pool of applicants. I think that would be a very valuable potential use of this work. So I do think that information is powerful. And potentially that information would allow workers and firms to make better decisions about what they're interested in asking for from the demand perspective.
Thank you. Let me ask you one last question. So Carrie is basically asking about the human behind the data here, asking how we hack the kind of ATS HR system and get out of the black hole and get to a human, and also makes the point that 60 to 80% of jobs may be in the hidden market that would not be visible here. So how would the research kind of address that sector that is not fully captured by the data? Yeah,
so I would love to know where Carrie got that statistic of 60 to 80% not being listed, because to me, I've been looking for a statistic like that, and I think that is interesting. So Carrie, if you have that, I'd love to hear. I do think that in a lot of ways, applicant tracking systems or softwares are changing. And so less jobs potentially, or at least I've heard from some recruiters or recruiting platforms, are potentially not going to be posted online. And they're just going to reach out to people based on their LinkedIn profile or other characteristics and ask them to apply for jobs. I think that we're not necessarily there yet, at least in the context of the academic market. We're required to post jobs, and most academic job market jobs are listed on a variety of different websites. And so I do think that we still have a lot of information available online, but I think that we will need to think about exactly or how to facilitate that change, and then who potentially will be marginalized in the process of that process changing.
Thank you so much. So that's it. This is all the time we have today. Thanks again, Sarah, for this very engaging talk and for the many audience questions. I know there are more questions than we have time for, so we will make sure to forward them to Sarah. So that's the last HAI seminar of the year. So please keep an eye out for the lineup for the HAI seminar speakers in 2022. Thanks again for joining. Thanks, Sarah. That was a lot of fun.
Perfect. Thanks so much, Jan, for hosting, and thanks, Hai, for making this possible.